When sizing an electrical box for splicing type SCR cables, the National Electrical Code Article 314.28 concerning pull and junction boxes doesn't specify the minimum size. However, National Electrical Code Article 312 regarding cable trays can offer some guidance. Specifically, Section 312.6a requires the box volume to be calculated using the sum of the cross-sectional areas of all cables contained within the box. Additionally, Section 312.6a limits the conductor fill to 40% for single-layer fill and 50% for multi-layer fill. To determine a suitable box size for splicing 12 SCR cables, with 6 cables in and 6 cables out, all with 1 American wire gauge conductors, perform the following calculations. Firstly, calculate the total cross-sectional area of the cables. 6 cables in, each with 1 American wire gauge conductors, contribute 10.56 square millimeters. Similarly, 6 cables out, each with 1 American wire gauge conductors, contribute another 10.56 square millimeters. The total cross-sectional area becomes 21.12 square millimeters. Secondly, calculate the box volume based on the cross-sectional area and box depth. Assuming a box depth of 150 millimeters, the volume is calculated by multiplying the total cross-sectional area of 21.12 square millimeters by the depth of 150 millimeters, resulting in 3,168 cubic millimeters. Thirdly, account for conductor fill. Assuming a 40% single-layer fill, divide the calculated volume of 3,168 cubic millimeters by 0.4, resulting in a required box volume of 7,920 cubic millimeters. Therefore, a box with a volume of at least 8,000 cubic millimeters would be suitable for splicing 12 SCR cables, 6 in and 6 out, with 1 American wire gauge conductors. Consider additional factors. Allow extra space for splicing connectors and wire nuts to ensure proper connections and ease of installation. Ensure the box has adequate knockouts or cable entry points to accommodate the incoming and outgoing cables. It is wise to consider using a larger box if you anticipate future expansion or require easier access for maintenance. Always consult with local authorities and a qualified electrical inspector for specific requirements and approvals to ensure compliance with local codes and regulations. The process involves calculating the total cross-sectional area of all cables entering and exiting the box, considering the conductor fill limitations specified in the National Electrical Code, and then determining the appropriate box volume based on these calculations. Don't forget to account for additional space for connectors and potential future expansion, and always seek guidance from local authorities and electrical inspectors to ensure compliance with all applicable codes and regulations. It's crucial to ensure all electrical work complies with the National Electrical Code and any local amendments to maintain safety and prevent electrical hazards. These codes and regulations are in place to protect both property and people from the dangers associated with improper electrical installations. When working with electrical systems, it's always best to err on the side of caution and seek professional advice if you're unsure about any aspect of the work. Electrical work can be dangerous, and it's important to take all necessary precautions to prevent accidents and injuries. Remember that while this video provides general guidance, specific requirements may vary depending on the location and the specific application. Always consult the latest edition of the National Electrical Code and local regulations to ensure compliance. When dealing with electrical installations, it is essential to understand the principles behind these codes and regulations, which are based on scientific and engineering principles that ensure the safe and reliable operation of electrical systems. Understanding these principles can help you make informed decisions and avoid potential hazards. For instance, the conductor fill limitations in the National Electrical Code are designed to prevent overheating and ensure that the conductors can dissipate heat effectively. Overfilling a box can lead to excessive heat buildup, which can damage the insulation on the conductors and potentially cause a fire. Similarly, the requirements for grounding and bonding are designed to provide a safe path for fault current to flow back to the source, which helps to protect people from electric shock. By understanding these principles, you can ensure that your electrical installations are not only compliant with the codes but also safe and reliable. Remember that electrical work is not a DIY project for untrained individuals. It requires specialized knowledge and skills, and it's always best to hire a qualified electrician to perform any electrical work. A qualified electrician has the necessary training and experience to ensure that the work is done safely and correctly. They will also be familiar with the local codes and regulations and can ensure that the installation complies with all applicable requirements. Trying to perform electrical work yourself without the proper training and experience can be dangerous and can potentially lead to serious injury or even death. It's always better to leave electrical work to the professionals. The National Electrical Code is a comprehensive set of standards that covers a wide range of electrical installations. It is updated every 3 years to reflect the latest technological advancements and safety practices. Staying up to date with the latest edition of the National Electrical Code is essential for anyone working in the electrical industry. The National Electrical Code is not law unless it is adopted by a local jurisdiction. However, it is widely used as a basis for electrical codes and regulations throughout the United States. Many local jurisdictions adopt the National Electrical Code with some modifications to suit their specific needs. Therefore, it is important to be familiar with both the National Electrical Code and any local amendments. In addition to the National Electrical Code, there are other standards and regulations that may apply to specific electrical installations. For example, the National Fire Protection Association, or NFPA, publishes a number of standards related to fire safety, including standards for electrical safety in the workplace. It is important to be aware of these other standards and regulations and to ensure that your electrical installations comply with all applicable requirements. When selecting an electrical box, it is important to consider the environment in which it will be installed. For example, if the box will be installed in a damp or wet location, it must be rated for that environment. Electrical boxes are typically rated according to the National Electrical Manufacturers Association, or NEMA, standards. NEMA ratings indicate the degree of protection that the box provides against environmental factors such as water, dust, and corrosion. Choosing the right NEMA rating is essential to ensure that the electrical connections inside the box are protected from the elements. In addition to the NEMA rating, it is also important to consider the material of the electrical box. Electrical boxes are typically made of metal or plastic. Metal boxes are more durable and can provide better protection against physical damage. Plastic boxes are lighter and less expensive, but they may not be as durable. The choice of material depends on the specific application and the environment in which the box will be installed. When installing electrical boxes, it is important to follow the manufacturer's instructions carefully. Improper installation can compromise the safety and performance of the electrical system. Make sure to use the correct type of fasteners and to tighten them securely. Also, be careful not to damage the box during installation. Damaged boxes should be replaced to ensure that they provide adequate protection for the electrical connections inside. When working with electrical systems, always remember to de-energize the circuit before starting any work. This is the most important safety precaution that you can take to prevent electric shock. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. Also, be sure to wear appropriate personal protective equipment such as safety glasses and gloves. The electric shock can be fatal, so it is important to take all necessary precautions to protect yourself. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to do the work for you. Electrical work can be dangerous, and it is important to have the necessary training and experience to perform the work safely and correctly. A qualified electrician can also ensure that the installation complies with all applicable codes and regulations. The information provided in this video is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before performing any electrical work. Electrical codes and regulations can be complex and vary depending on the location. It is important to stay up to date with the latest codes and regulations to ensure that your electrical installations are safe and compliant. By following these guidelines and taking the necessary precautions, you can ensure that your electrical installations are safe, reliable, and compliant with all applicable codes and regulations. Remember, safety is always the top priority when working with electrical systems. Take your time, be careful, and always consult with a qualified professional if you have any questions or concerns. Ensuring the electrical box is properly sized, grounded, and protected is critical to prevent electrical hazards and ensure the longevity of the electrical system. When considering additional space for splicing connectors and wire nuts, factor in the physical size of these components. Different types of connectors and wire nuts occupy varying amounts of space. For example, some connectors are bulkier than others, and some require more space for proper insulation and strain relief. Overcrowding the box can lead to damaged insulation, loose connections, and potential short circuits. Providing adequate space ensures that the connectors and wire nuts can be properly installed and maintained. When selecting an electrical box, consider the number and size of the knockouts. Knockouts are the pre-cut openings in the box that allow cables to enter and exit. Ensure that the box has enough knockouts to accommodate all the incoming and outgoing cables, and that the knockouts are the correct size for the cables being used. If the knockouts are too small, you may have to enlarge them, which can weaken the box and compromise its integrity. If the knockouts are too large, you may have to use adapters to seal the openings properly. Using the correct size and number of knockouts ensures that the cables can be properly installed and protected. When considering future expansion, think about the potential for adding more circuits or equipment in the future. If you anticipate needing more electrical capacity in the future, it is wise to install a larger box now to accommodate those future needs. Installing a larger box now can save you time and money in the long run, as you will not have to replace the box later when you need to add more circuits. Also, consider the accessibility of the box. Make sure that the box is located in a place where it can be easily accessed for maintenance and repairs. If the box is located in a hard-to-reach place, it may be difficult to work on it in the future. Always consult with local authorities and electrical inspectors to ensure that your electrical installations comply with all applicable codes and regulations. Local authorities and electrical inspectors are familiar with the specific requirements in your area, and they can provide valuable guidance to ensure that your installations are safe and compliant. They can also help you interpret the National Electrical Code and any local amendments. Consulting with them early in the process can prevent costly mistakes and ensure that your installations meet all the necessary requirements. The selection and installation of electrical boxes are important aspects of electrical work that should not be overlooked. By following these guidelines and taking the necessary precautions, you can ensure that your electrical installations are safe, reliable, and compliant with all applicable codes and regulations. Always prioritize safety when working with electrical systems, and never hesitate to seek professional advice if you have any questions or concerns. In summary, correctly sizing an electrical box for splicing SCR cables involves a careful consideration of several factors, including the number and size of the cables, the conductor fill limitations, the space required for connectors, the potential for future expansion, and the applicable codes and regulations. By following these steps and consulting with qualified professionals, you can ensure that your electrical installations are safe, reliable, and compliant. Also, when working with electricity, it's always best to have a professional do the work if you are not experienced or qualified. This ensures the safety of yourself, others, and your property. Incorrect electrical work can lead to dangerous situations such as fires or electrocution. In addition to these considerations, remember the importance of proper grounding and bonding within the electrical box. Grounding provides a safe path for electrical current in the event of a fault, helping to prevent electrical shock. Bonding ensures that all metallic parts of the electrical system are at the same electrical potential, reducing the risk of electrical shock and minimizing electromagnetic interference. Make sure that all grounding and bonding connections are properly made and securely fastened. Also, consider the use of surge protection devices to protect sensitive electronic equipment from voltage spikes and surges. Surge protection devices can be installed at the electrical panel or at individual outlets to help prevent damage to electronic devices. Protecting your electronic equipment from surges can extend its lifespan and prevent costly repairs. Furthermore, ensure that the electrical box is properly labeled to identify the circuits and equipment that it serves. Labeling helps to prevent confusion and ensures that the correct circuits are de-energized when performing maintenance or repairs. Use a permanent marker or label maker to create clear and easy-to-read labels. Place the labels on the inside and outside of the box for easy identification. Regularly inspect your electrical boxes and connections to identify any signs of damage or deterioration. Look for loose connections, corroded wires, cracked insulation, or other problems. If you find any issues, address them promptly to prevent further damage and ensure the safety of the electrical system. Regular inspections can help you identify potential problems before they become serious. Remember that electrical systems require ongoing maintenance to ensure their safety and reliability. Taking care of your electrical system can prevent costly repairs and ensure the safety of your home or business. Staying informed about electrical safety practices is crucial for anyone working with or around electrical systems. Educate yourself about the hazards of electricity and the steps you can take to prevent accidents. Attend training courses, read industry publications, and stay up to date with the latest codes and regulations. By staying informed, you can make informed decisions and protect yourself and others from electrical hazards. The content of this video is meant for informational purposes only and does not constitute professional advice. Always consult with a qualified electrician or electrical engineer for specific guidance related to your electrical projects. Electrical codes and regulations vary by location, so it's essential to ensure compliance with all applicable requirements in your area. Prioritizing safety is always the most important consideration when working with electrical systems. Take your time, be careful, and never hesitate to seek professional assistance when needed. Remember to always disconnect power before working on electrical circuits. Test circuits with a reliable voltage tester to ensure they are de-energized. Wear appropriate personal protective equipment such as insulated gloves and safety glasses. Use tools that are insulated and rated for electrical work. Never work on electrical systems in wet or damp conditions. Be aware of your surroundings and avoid distractions. Keep a clear workspace and avoid clutter. If you are unsure about any aspect of electrical work, seek assistance from a qualified professional. With proper knowledge, training, and safety precautions, you can work safely and effectively with electrical systems. Electricity is a powerful force that can be both beneficial and dangerous. By respecting electricity and following safety guidelines, you can minimize the risks and enjoy the benefits of this essential resource. Consider the impact of your electrical choices on the environment. Choose energy-efficient appliances and lighting to reduce your energy consumption and minimize your carbon footprint. Conserving energy not only saves you money, but also helps to protect the planet. Educate others about electrical safety and energy conservation. Share your knowledge with friends, family, and colleagues. By raising awareness, you can help to create a safer and more sustainable world. Together we can make a difference.